It starts with a question that feels almost wrong to ask. What is the biggest thing in the entire universe? Not the sun, not a galaxy, not even the web of galaxies we think we know. The answer isn't simple, and that's the hook. Astronomers have spent decades trying to map the cosmos, measuring structures so huge they don't even fit in your imagination. Picture a star so massive that if you dropped it in the middle of our solar system, it would swallow planets whole. Now scale up past stars, past clusters, to things stretching millions of light years. Here's the twist. These cosmic giants aren't just pretty, they carry secrets about how the universe was born, how it's changing, and how it might end. And before you think this is just another science lecture, remember, the stakes couldn't be bigger. Because if we're wrong about these structures, we're wrong about the fate of everything. If you want to keep uncovering these cosmic mysteries with me, hit subscribe now. Don't be the one left in the dark. Imagine a star so colossal that the word giant feels like an understatement. Astronomers call it Stephenson 2-18, and it makes our sun look like a candle beside a bonfire. This red supergiant stretches nearly 1,000 times wider than the Sunday drop it into the middle of our solar system, and its surface would swallow Mercury, Venus, Earth, Mars, and even Jupiter. That's not just big, it's terrifying. Because stars this massive live fast and die violently. While our sun will quietly fade into a white dwarf, Stephenson 2-18 is destined for a supernova, a cosmic explosion so powerful it can outshine entire galaxies. And here's where the mystery deepens. What's left after that blast? A neutron star crushed into atomic density, or a black hole gravity's ultimate trap? The answer matters because it shows us how matter recycles, how galaxies breathe, and how new worlds are born from destruction. Every massive star carries a ticking clock, and when it strikes zero, the ending is anything but peaceful. Inside a red supergiant's core, elements fuse in a desperate race, hydrogen to helium, helium to carbon, heavier and heavier until iron appears. But iron is the dead end. It can't release energy through fusion, so the core collapses under its own unimaginable weight. In less than a second, matter is crushed to densities beyond comprehension, and the outer layers rebound in a blast we call a supernova. For a brief moment, the dying star shines brighter than every other star in its galaxy combined. The debris it hurls into space carries the raw materials for planets, oceans, even life itself. Yet in the center, something new is born. Either a neutron star, a city-sized ball heavier than the sun, or a black hole, a one-way doorway where physics itself bends and breaks. If red supergiants are titans, then hypergiants are monsters. VY Canis Majoris is one of the most unstable stars ever found, 1,500 times wider than the Sunday. Picture it, a fiery sphere so enormous that if it sat where our sun is, its surface would stretch past Saturn's orbit. But here's the twist, it's literally tearing itself apart. Immense convective eruptions bubble to the surface, blasting out clouds of gas and dust larger than entire solar systems. Surrounding it is a nebula, an enormous shroud of material ejected in violent fits, like a dying giant coughing its last breaths. Astronomers believe stars like this don't live long. Their massive size is both their crown and their curse. They burn fuel so ferociously that their lives are measured not in billions of years, but in just a few million. And when they go, the universe takes notice with explosions that rewrite galaxies. At the heart of nearly every galaxy lurks a secret, a black hole so massive it defies comprehension. These aren't just collapsed stars, they're supermassive black holes, millions or even billions of times heavier than the Sunday. What's eerie is how closely their growth mirrors that of their galaxies. The bigger the galactic bulge, the bigger the black hole at its core. It's as if the two are locked in a hidden partnership, shaping one another's destiny. Scientists think this connection isn't coincidence, it's feedback. As gas falls toward the black hole, it heats into a blazing disk, releasing energy that can sweep through the galaxy. That power can snuff out star formation, turning fertile regions into barren voids. In other words, black holes aren't just destroyers, they're regulators, galactic gatekeepers deciding when new stars are born and when the lights go out. When gas spirals into a supermassive black hole, it doesn't vanish quietly. Instead, it forms an accretion disk matter whipped into a storm hotter than the core of any star. Friction and gravity tear particles apart, releasing torrents of radiation that blaze across the universe. But the real spectacle comes when the black hole unleashes jets. Beams of plasma, traveling near light speed, erupt from its poles, shooting millions of light years into space. These jets can scorch their host galaxies, heating or expelling the very gas needed to form stars. It's cosmic regulation by violence, black holes acting less like silent predators and more like galactic referees. They decide whether a galaxy thrives with newborn suns or withers into silence. The paradox? The most destructive forces we know might also be the architects of cosmic balance. For decades, the center of our Milky Way looked like a quiet patch of stars, but astronomers suspected something invisible, something monstrous, was hiding there. The proof came from one star, S2. Every 16 years, it whips around an unseen point, moving at speeds so extreme it defies belief. No visible object lies there, no cluster of stars could explain it. The only answer is a black hole, 4 million times heavier than the Sun, crammed into a space smaller than our solar system. We call it Sagittarius, A*. And watching S2 orbit, it is like watching gravity itself at work, an invisible hand yanking a star in a deadly dance. For the first time, we weren't just theorizing black holes. We were watching one dictate the motion of a star, confirming the monster in our backyard was real. Just when you think black holes can't get any bigger, the universe drops a monster like TON 618. This quasar isn't just bright, it's blinding, shining with the light of trillions of suns. At its heart sits a black hole so enormous it breaks imagination, more than 40 billion times the mass of the Sunday. To put that in perspective, if our solar system orbited inside it, we wouldn't even graze its edges. And here's the haunting part. The light we see from TON 618 left over 10 billion years ago. We're staring back in time at a cosmic engine that was already fully grown when the universe was young. It devoured matter with such ferocity that it became a lighthouse across intergalactic space. And yet, even with all our telescopes, we can only glimpse the surface of its fury. If you think galaxies are just scattered islands of stars, meet IC 1101. This Leviathan stretches 500,000 light-years across so vast, our entire Milky Way would vanish inside it like a speck of dust. But IC 1101 isn't alone. In crowded clusters, galaxies grow by consuming their neighbors, merging again and again until they become behemoths. ESO 383-76 is one of these monsters, possibly reaching nearly 2 million light-years wide. Imagine a single galaxy holding trillions of stars, each with its own worlds, yet bound into one colossal structure. And beyond even that scale, the universe threads galaxies together with invisible filaments, dotted by glowing gas clouds called Lyman alpha blobs, and radio lobes that stretch millions of light-years. These aren't just the largest things we've found, they're the scaffolding of the cosmos itself, the architecture of everything we know.